Hello everyone. In this video, I'm going to do work examples on the use of the relation between arcs, chords, and angles. Example 1. In the figure, you are given this kind of information. In part A, you need to find angle AC boy. To find angle AC boy, we know that first, angle CA boy is equal to angle C boy A. Which is base angles, isosceles triangle. And thus angle C boy A is 75 degrees. And angle AC boy can be found by the sum of this and angle C boy A and angle CA boy. Angle sum of triangle. And thus angle AC boy is 30 degrees. Now for part B, you are asked to find the circumference of the angle of the circle in terms of pi. And in this question, you can do it in two ways. Number one, make use of the proportional relation between arcs and angles. To do that, we can first find the arc length of AC. Since AC is equal to BC, so we have the arc length of AC is equal to the arc length of BC. It is equal chord, equal arc. And thus the arc length of AC is 15 pi cm. And next, we should find the arc length of AB with, say, the arc length of AC or BC is up to you. BC is the same as angle AC boy over angle CA boy. And the reference is arcs proportional to angle at the circumference. And thus you should find the arc length of AB is about 6 pi cm, and thus you should find the circumference of the circle. Is the length of AC, the length of BC, and the arc length of AB, and is 36 pi cm. Okay, so this is example 1. Now example 2, you are given a question like this, and BE is parallel to CD, and you are asked to find the arc length ratio AB to BC. And that means we need to find the angle at the center or angle at the circumference about the arc length of AB and BC. And of course, we need to use the parallel lines. Now in the figure, we know that the angle at the circumference of the 2 points BC is 24 degrees, so we can do it for the arc length BC. And what about the arc length of AB? The arc length of AB, the angle can be this angle. And that means we need to find this angle with the help of 60 degrees. Now, since point E is parallel to CD, we then try to make use of the angle properties about parallel lines. And thus you should think about this as 24 degrees. And by considering triangle BDF, you should find out that this angle ADB is 36 degrees. Okay, and thus you can find the results. So first of all, we need to find this angle, but basically we find this angle 24 degrees first. So we have angle DBE equals angle BDC is the alternate angles BE parallel to CD, and thus angle DBE is 24 degrees. And we consider triangle BDF, that angle AFB is the sum of angle DBE plus angle ADB, exterior angle of triangle. Then you can find angle ADB is 36 degrees. And finally, since the question is asking about ratio of the arc lengths, so instead of having a fraction, you can directly apply to the ratio. And thus, finally, we have the arc length ratio AD to BC is the angle ADB to angle BDC. The reference is arcs proportional to angles at the circumference. And thus is 36 degrees to 24 degrees, so it's 3 to 2. Okay? So this is example 2. And last example of this video, example 3. Okay, look at the question here. We have the arc length AD is equal to BC, and two angles with one side AE is given. Now, part A, you need to find an angle ACD. Angle ACD is here, and the angle ACD is the angle at circumference from the 2 points A and D, where the arc length of AD is equal to the arc length of BC. So if we consider the angle at the circumference from 2 points B and C, that is here, these two angles are the same. And thus, with the help of 110 degrees, we can find out the size of angle ACD. Okay, so let's find it out first. Part A, AD equals BC, which is given. And so we have angle ACD is equal to angle BDC, which is equal arcs equal angles at circumference. Okay, but once when you are talking about arc, the relation between arcs and angles, when they are of equal length, you can also use the reference arcs proportional to angles at circumference. Okay, the ratio is 1:1, so you can use the proportional relation reference, or you can use the equal arcs, equal angles as circumference reference. Okay. Now, in triangle CDE, we have angle ACD plus angle BDC plus angle CED is 180 degrees. Okay, angle sum of triangle. And since we are asking to find ACD, so we have 2 of angle ACD equals 70 degrees, and hence angle ACD is 35 degrees. Okay, so this is part A. Now part B, you are asked to find the length of BE. You are given AE to be 10. Now, whenever we are talking about length, okay, we need to be very careful whether it's about the chord with the center, something related to perpendicular bisectors of chord, etc. This is the first way. And second way, make sure you need to make use of congruent and similar triangles, or even right angle triangle if there's a right angle triangle. Okay. So for the length of BE, it may be of some relation between AE and BE. Then if I want BE to be 10, say, then I need to prove some congruent triangles, or you prove 2 base angles equal in a triangle to conclude the 2 sides being equal, right? So because we have equal arcs, so we can deduce the 2 chords are equal. And what do we have? We have 4 points on the circle with AC intersect BD at point E, and so we can consider angles in the same segment. So this is 75, and also we can use angle in the same segment again, or vertically opposite angles to conclude the 2 triangles being congruent, and thus BE is actually equal to 10. Okay. Now, so BE is equal to 10, so we just need to present it properly. And since it involves a proof of congruent triangles, you need to write clearly the proof. So part B, since AD is equal to BC, which is given, so we have AD equals BC is equal arcs equal chords. Okay, and angle AED is equal to angle BEC, which is vertically opposite angles. And next we have angle DAE is equal to angle CBOE, angles in the same segment. And thus we have triangle AED is congruent to triangle BEC, and the reference is AAS, and thus BE is equal to AE, which is the corresponding sides congruent triangles, and thus BE is indeed 10. Okay. So at last, part C. Part C, Someone claims that the incenter of triangle ACD lies on BD. Do you still remember what the incenter of a triangle is? The incenter of a triangle is formed by angle bisectors of the three interior angles of the triangle. And for triangle ACD, if we consider this line, if the two angles here are equal, that means BD is actually one of the angle bisectors of triangle ACD. And in this case, the incenter of the triangle ACD must lie on some point in between B and D. So what you need to prove or show is that BD is indeed an angle bisector, and that means whether these two angles are equal. Okay. In part A, we find that angle ACD is 35, and so as this one, angle BDC is also 35. So what do we need to prove is whether it's 35 or not. And indeed is yes, because we have 75 plus 35 being 110. And so the answer for this one is yes, and let's write down. Part C, in A, angle BDC equals angle ACD is 35, and then consider, okay, actually you may consider the interior angles of triangles here in ACD instead of using exterior angle of triangle. But anyway, I will consider the exterior angle of triangle. Consider triangle ADE. We have angle DAE plus angle ADE equals angle CED. Exterior angle of triangle. And thus angle ADE is 35 degrees. And since angle ADE is equal to angle BDC, then we have two things. One, so BD is an angle bisector of angle ADC. Okay, this is the immediate results from the fact that angle ADE is equal to angle BDE. And thus, what's the meaning of BD being an angle bisector of ADC? We can say that the incenter of triangle ACD lies on BD. And thus, the claim is agreed. Okay, so this is the answer of part C, and that's all for the video about the examples about the relation between arcs, chords, and angles. Okay, and there is one more video coming up about the use of the chord relations with arcs and angles in MC. Okay, so stay tuned and thanks for watching.